Hi everyone, welcome in new energy efficiency tip of the day. The subject will be how we can optimize the pumping system piping configuration. First of all, there are three areas we need to consider when we are optimizing the configuration for the whole pumping system. The first part we need to optimize will be finding a proper size for the pipe. The problem, we need to make a balance between the initial cost by selecting large pipes that will definitely have a higher cost, and the cost of pushing fluid if we select the small pipes that have a high pressure drop. So we need to optimize between the initial cost and the running cost for the system. The second area we need to optimize will be designing the piping layout in a way that minimizing the pressure drop. The third area will be selecting a low pressure drop component for the whole system, so the overall energy efficiency or the energy consumption for the whole piping system will decrease if we selected equipment or part of the system like heat exchanger or other consumer of the liquid with a lower pressure drop. Usually there are three common pipe configuration problems that we will find. The first problem will be improper flow profile. In this regard, you will find also some cases people using low radius elbow before the pump inlet, and this will cause a high pressure drop on the suction, or using a globe valve just upstream the pump. Both of those two actions will cause high pressure drop on the suction, as we mentioned, and this will cause a cavitation because the pressure at the suction can go below the vapor pressure of the liquid, and this will cause a cavitation on the long run, and this will have a significant damage on the pipe impeller and the performance of the pump. The second problem will be having vapor collection on the suction. If we can see here that the suction pipes should not have this kind of bending that allow for a small bucket of air at the suction, and should be correctly done in inclined way in order to avoid this kind of bucket. This also another very common problem when people using this V shape on the suction instead of the correct eccentric or eccentric pipe configuration that will not allow having this pocket like this one here. We have seen also people using different pipe size fitting like this one here. The correct configuration will be using the small or the same size of the fit to avoid any air gap or air pocket here. The third problem will be having a vortex formation on the suction of the pump. In order to avoid that, we will install a vortex breaker. This vortex breaker will not allow the liquid, when it goes to the suction of the pump, to have a rotation movement when it is going to the suction of the pump. This movement or this rotation or this vortex can cause a cavitation also on the suction of the pump, and we need to avoid that by installing this one. In some cases, they install the same pattern of this vortex formation on the discharge also. In order to summarize what we have described today, the solution would be thinking about how we can properly make the balance between the initial cost and the running cost, and not only focusing on the initial cost of the equipment or selecting a small equipment, small pipe size that will have a definitely higher running cost, and this will be very huge comparing to the one that we have saved in the capex or the capital cost for the whole project. Also, following the standard and good practice will give us a clue how we can select properly most of the piping diameter, or what is the best delta B allowable for most of the equipment that we are selecting. For example, don't go more than 3 meters per second in most of the liquid piping system when you are selecting the pipe diameter for your system. Thank you so much. This was a quick tip. If you want, you can download a PDF format of this tip in order to share it with your colleagues, or even to keep it for you in the future for any reference. And please try to visit our website, Energy Efficiency or 360 Proactive Engineer, for more tips. Thank you so much, and any improvement comments are welcome from your side in order to improve what we are providing for you. Thank you so much, and see you in the next step.